Okay, let's dive in. We're looking at the future of power, and, well, based on these materials from the IAPEL's conference, the message seems pretty clear.
It is. The electrical grid as we know it is basically obsolete.
Right, it's facing this huge system-wide transformation.
Yeah.
So our mission today is to really get into the forces driving this change and figure out what this dynamic grid ecosystem actually is.
And the scale of this shift is just enormous. It's being pushed by, three global megatrends you just can't ignore. The first is decarbonization.
Which makes sense.
Yeah, I mean, electricity generation alone was responsible for about a quarter of total greenhouse gas emissions back in 2022. Then number two is the massive influx of renewable energy.
And we saw that hit, what, 29% of global generation that same year?
Exactly. And that leads right into the third trend.
Deep electrification.
Yeah.
And this is where the demand side just explodes. We're talking about EVs, sure, but the really critical piece seems to be these new large-scale data centers.
Oh, absolutely. Their power demand is 10 to sometimes 100 times higher than traditional centers.
100 times. And the projection is that they could be using up to 12% of all U.S. electricity by 2028. That's a staggering amount of new concentrated demand.
It is. And that's the collision course we're on. You have that massive demand hitting the variable nature of renewables, what we call VRES.
VRES, right. Variable renewable energy sources.
Wind and solar. And this combination creates the central problem, rapid fluctuation. The source data shows a really strong link between more VRES on the grid and a rise in things like curtailment.
Which is where we're just wasting perfectly good renewable energy.
We're just throwing it away. That and load shedding, which is when you, the customer, lose power. The old centralized grid just wasn't built for this. It can't react.
So if the old system is overwhelmed, what's the architecture for this new dynamic grid ecosystem? What does it look like?
The whole character of the grid has to change. The goal is to evolve into, well, an ecosystem of millions of independently owned, smaller power sources.
These are the DRRs, the distributed energy resources.
That's right. And they all have to be coordinated in real time.
But the real shift there is in the control system, isn't it? We're going from a grid that relied on heavy spinning turbines, electromechanical inertia, to one that's dominated by fast-acting inverters, IBRs.
Yes, inverter-based resources. That's the technological heart of the change. You're swapping physical stability for algorithmic stability.
It's like going from a heavy cruise ship that takes miles to turn
to a coordinated fleet of millions of agile speedboats. They can change direction instantly with digital commands. It's a total control overhaul. The IBRs, the brains of a solar farm or a battery, they become the foundation of grid stability.
So let's talk about a tangible example. Nick Singh from Eskom in South Africa presented a really fascinating case study.
He did. They're taking the decommissioned Komati Power Station, a huge 1 gigawatt coal plant, and instead of just demolishing it, they're repowering and repurposing it.
So what does that involve?
Solar, wind, and battery storage right on the site. But crucially, they're also building a microgrid assembly plant and a renewable energy training facility there.
So it's not just about clean energy, it's about jobs and energy access too. I think the source said over 4 million people in South Africa still lack electricity.
Exactly. It tackles both problems at once. It's a perfect application of this dynamic ecosystem idea.
And that connects to what Alexandre Udalov was saying, that flexibility across the whole system is key.
Yes, his point was that without that ability to shift energy around quickly, we're just going to waste enormous amounts of renewables and consumer costs are going to skyrocket. And the only way to get that flexibility is with power electronics and digital tech.
So the technology is one part of the puzzle. But the session also flags some major gaps that aren't technical at all.
Right. First, the regulations. Existing regulatory frameworks are just not built for this kind of fast, decentralized world. Second, utilities need new business models.
Especially ones that give them a return on investment from behind-the-meter benefits. And just to clarify for everyone listening, that basically means finding a way for utilities to make money from things like your rooftop solar or your home battery to get them incentivized. And the last piece, we just need smarter system-level thinking, maybe even moving towards hybrid AC and DC grids to handle those huge data center loads.
So it's clear from all the sources, managing millions of new power sources and these massive new loads, it just demands a radical solution, the dynamic grid ecosystem.
And that leaves us with a really interesting final thought for you. This whole transition shows this strange convergence of needs between the global north and the global south. Developed nations have aging grids, Developing nations have energy access issues.
So the question is,
How can these greenfield opportunities in places like South Africa be used to leapfrog straight to a 21st century grid? And in doing so, what lessons can they offer the developed world that's struggling to upgrade its own legacy infrastructure?